For most of history, the case for God was a matter of faith. You believed or you didn't. But over the last century, something strange happened. Mathematicians, some of the sharpest minds who ever lived, started building arguments for God's existence, using pure logic and formal equations. Not sermons, not scripture. Math. Here are 9 of them. Number 1. Gödel's ontological proof. Kurt Gödel is considered one of the greatest logicians in human history, the man who reshaped the foundations of mathematics itself. With his incompleteness theorems, near the end of his life, he left behind a formal proof, written in modal logic, for the existence of God. He defined God as a being possessing every positive property there is. Every property that is, in a precise logical sense, good rather than a limitation. Then, working entirely from a small set of axioms, he showed that if such a being is even possible, if the concept doesn't contain a hidden contradiction, then it must necessarily exist. Not might exist. Must. For decades, Gödel's proof lived quietly in his private papers, only published after his death. Then in 2013, 2 computer scientists took his exact argument and ran it through automated theorem-proving software. Programs built to check, line by line, whether a piece of formal logic actually holds together. The software confirmed it. Every step of Gödel's reasoning was logically valid. A machine, incapable of belief or bias, verified that one of the 20th century's greatest mathematical minds had built an airtight logical structure pointing toward God. Number 2. The fine-tuning of the cosmological constant. The cosmological constant controls how fast the universe expands. For a universe capable of forming galaxies, stars, and life, that number has to be balanced with almost unimaginable precision. Physicists put the required accuracy at roughly 1 part in 10 to the 120th power. To picture that number, it's like hitting a target the size of a single atom, from across the entire observable universe, in a single throw. Nudge that constant even slightly in either direction, and the universe either flies apart into empty nothingness, or collapses back in on itself before a single star can form. One number, tuned to a precision beyond anything human engineering has ever achieved, sitting quietly at the foundation of everything that exists. Number 3. The broader fine-tuning of physical law. It isn't just one constant doing all the work. The strength of the strong nuclear force, the mass of the electron, the ratio between gravity and electromagnetism. Physicists have identified dozens of independent numbers that all had to fall within a narrow range for atoms, stars, and chemistry to even be possible. Change almost any of them even slightly, and you don't get a slightly different universe. You get no universe capable of producing anything at all, no atoms heavier than hydrogen, no stars, no chemistry, no observers to ever notice the difference. Number 4. The Kalam cosmological argument. This one leans on the mathematics of infinity itself, an actual, completed infinity. Not just a mathematical concept on paper, but a real, physical infinite series of past events. Creates genuine logical contradictions. Mathematician David Hilbert illustrated this with a famous thought experiment. A hotel with infinite rooms, every single one already occupied, that can somehow still make room for infinitely more guests through an impossible shuffling of who moves where. If actual infinities can't exist in the real, physical world, then the chain of causes behind the universe can't stretch backward through infinite time. It has to start somewhere, with a first cause, itself uncaused by anything that came before it. Number 5. The unreasonable effectiveness of mathematics. In 1960, physicist Eugene Wigner wrote a now famous essay, asking a simple but genuinely strange question. Why does abstract math, invented in human minds with no reference whatsoever to the physical world, end up describing that world with uncanny, almost impossible precision? Equations dreamed up purely for their internal elegance, decades before any related physical phenomenon was even discovered, later turn out to precisely predict real particles, real forces, real observable events. Wigner called it a gift we neither understand nor deserve. Some mathematicians argue the only truly satisfying explanation is that the universe itself was built on an underlying mathematical structure by a mind capable of designing it that way from the start. Number 6. The golden ratio and the Fibonacci sequence. A single mathematical pattern, the ratio of roughly 1.618 to 1, shows up again and again across the natural world. In the spiral of a nautilus shell, the arrangement of seeds in a sunflower head, the branching pattern of trees, the proportions of the human body. It's not one isolated coincidence, or even a handful. It's the same underlying numerical code, repeating at wildly different scales, as if it were written once, somewhere, and reused everywhere since. Number 7. The probability of a single functioning protein. Life depends on proteins, precise chains of amino acids, folded into exact three-dimensional working shapes. Some researchers have calculated the odds of even one simple protein assembling correctly through pure random chance, at somewhere around 1 in 10 to the 113th power. Proponents of this argument compare it to a tornado tearing through a junkyard, and, by pure accident, assembling a fully functioning airplane out of the scattered scrap. And a single protein isn't nearly enough on its own. A working, living cell needs hundreds of different proteins, each correctly formed, all present and functioning at once. Number 8. Leibniz's principle of sufficient reason. Philosopher and mathematician Gottfried Leibniz, the same mind who co-invented calculus alongside Newton, argued that everything that exists must have a reason for its existence, some explanation for why it's there instead of not. The universe itself, he pointed out, is contingent. It didn't have to exist the way it does, or exist at all. So what actually explains it? Leibniz's answer was that the chain of reasons has to terminate somewhere, in something that exists necessarily, by its own nature, requiring no external cause beyond itself. And that, he argued, is what people mean when they say God. Number 9. Mathematical Platonism. Numbers, geometric shapes, and logical laws seem to exist independently of any human mind that thinks about them. 2 plus 2 equaled 4 long before anyone existed to work it out, and it will remain true long after everyone capable of thinking about it is gone. So where, exactly, do abstract mathematical truths actually live? Some mathematicians argue they exist in something like a mind, eternal, unchanging, transcendent, outside of space and time, and that human mathematical reasoning only works at all because it's tapping into that same underlying order. 9 different mathematicians and physicists, working across 3 centuries in completely different fields, logic, cosmology, biology, philosophy, independently arrived at strikingly similar conclusions, approaching from completely different directions. Each one found the numbers pointing somewhere beyond themselves. It's worth being upfront about one thing. Every argument here remains genuinely debated among mathematicians and philosophers, including by people of deep religious conviction on both sides. But debated doesn't mean dismissed. It means this remains one of the most seriously contested questions in all of mathematics and philosophy, argued over for centuries by some of the most rigorous minds who ever lived.